Hi there guys, today we're going to look at controlling a Arduino unit or it's more popularly called a SCADA system. It's all about system collecting and analyzing data and giving you a user interface on your computer to control some units around. Well, it's very popular and well known in a factory to use this system. I've made several attempts to find something that would work with Arduino, and I've failed a lot. And I found a lot, and I do mean a lot of software on the web where they claim to have this SCADA system for the Arduino, and it works out of the box, except you need this and that, and you need to install these libraries, and well, okay. That's not my style. I just like to make things work as they are. So that's what I have done. I'm using, as you can see on screen, this window right here. That's Arduino's own GUI. And I'm using version 1.5.8. I also did this with 1.0.6, I believe it's called. That's the other one you can choose. I'm not sure how to remove the About button again. Oh, just click it. That's fine. The other thing I'm going to use is Visual Studio Express. And check this out. It's version 2013 and a junk load of serial codes. And I'm not worried about it. It's free. So just head over to Microsoft and download Visual Studio Express. Okay. I'm now going to use my handheld, if you want, my GoPro Hero 3, and record my Arduino, which is right here on the table right in front of me. And while recording that, I'm going to hold it like this because I don't have a stand or anything. I'm going to show you on screen this thing I made in Visual Studio. It's actually a GUI to control my Arduino, and my the functions are really simple. And what I really wanted to make sure is that I could receive data through a serial connection and send data back, meaning I can control something through the Arduino. And it works. It's just a matter of interpretation of the code. So let's do it without further ado. Let's hit start up here, and you can see, well, I'm just going to minimize this window and put it right here where I got my recordings as well. And like, all you got to watch is this window. I'm now going to turn on my camera, I think. Yep, there we go. And I don't know if it's watching the Arduino because, as you know, the GoPro has no view function. But I'm holding it straight above. And let me just explain a few things, what's going on here. The three things on the board. The first thing is this one. That's the temperature gauge or sensor. It just measures temperature. This one right here. Let me take something to point with. Let's click that out. This one right here is a LDR light resistor. It increases resistance depending on how much light is on it. And the last thing are just two LEDs. They are all powered via 5 volts, as you can see. 5 volts from the Arduino. And it's just hooked up to ground right here. I'm measuring at 2 points, as you can see, analog 0 and analog 1. The yellow wire measures, let's see, the light sensor, and the orange wire measures the temperature. These two over here are just sending power to the LEDs if they are supposed to be turned on. Okay, now let's watch the screen. So when I hit update, of course, you can just build this into a loop, but I've just built it into a button because, yeah, I like to keep things in control. The value up here, right now there's nothing, but that's the value this sensor reads. The value here in Celsius is the value the temperature gauge reads, except that it's recalculated because the actual feedback is just the amount of voltage. On screen, you can see that I have an on-off function here. That's actually to turn the green LED on and off, which of course makes this sensor react. You could also use it to turn on off relays if you want. I have a strong or very slow delay for debugging. As you can see, my delay is 5,000 milliseconds. That's 5 seconds. So from when I click this button, it takes at least 5 seconds before it updates. But that's fine. Arduino is on comfort, and we're running at a 9600 baud. So let's just test. Update. And you can see the yellow light turned on. That's just a reflection of it's sending and receiving data. That's it. So don't worry about that. You can see the light sensor measured 83. That's because I have a very sharp light above me. So it's a high value. The temperature is 21.3 Celsius. So that's working. If I click update again, you'll see it takes a few seconds to actually react. The light turns on and I get a new reading. 21.78, still 83. So let's imagine this is a pump and I want to turn it on, so I just hit the on switch and update. This turns on the green light instantly on the board. That means I can send messages back and forth between the units. Turn the light off if I want, and you can see there's a small delay, but it actually works. So now you ask, what can I use that for? Well, in a real factory, they use something called a PLC, and PLC units is similar, but not really, to the Arduino. It's small control units that can control sensors and actuators, things to turn on and off, basically switches, and that's what we got here with the Arduino right now. So the green light is actually just a switch for me. So let's turn this program off and you can see what's going on. Let's go into the code because I'm sure that's what most people are interested in. First of all, let's check out the Arduino code. It's really simple. It might seem long, but actually is not so bad. I will make the code available. I'll put a link in the description below the video. First of all, you can see I'm just declaring. I used to have included these libraries because I did a lot of debugging and I tried a lot of things on the Arduino forum. But yeah, as you know, there's a lot of crazy people there. So, a lot of naysayers, if you want. First of all, just declaring the variables I'm going to work with. And it's mostly just pins, but this one is important. Incoming bytes, that's actually, excuse me, when I send a signal through the Arduino, through the USB cable, it's a serial communication. And it's going to read that in bytes and sometimes ASCII characters. So it's important to know how much data is I'm going to receive through this cable. Well, right now we have set it to 2 bytes. Well, what does a byte mean? Well, it's just a number. And in my case, I'm using the numbers represented by the letters on the keyboard. We'll get back to that, but it says 2. That's actually because I'm sending 3 values back and forth, because remember to count 0 with it. The string is read string. It's also important because we're going to read the signal as a text string. first of all, before we're going to turn the signal into numbers, let's move this down a bit so we get them separated. The setup void, we just got a serial connection, and this is important, else we wouldn't be able to do this. And set the pin modes. That's it. Okay, let's separate this as well. This entire thing is the loop itself. So let's skip this part first and take the last part. This part down here is actually what does the functions, and this is what most people already should know. We take a integer, the temperature Celsius value, and we read it off the analog pin, just like you always do. And we recalculate it into Celsius. We turn a voltage into a degree. So that's it. Same thing for the light value. We just turn the light read into a float, and that's why we get this nice number. Otherwise, you would get something like a number between 0 and 1023. So yeah, what's that? It's easier to say, well, if we turn it into a float, we can kind of say, well, it's 100% or 0%. And what we saw was kind of 83% resistance. That's easier to understand. What we got here? Serial print. Well, this is actually how we are sending the signal to the PC. Let's just ignore that one. That's just even more calculations. Ignore that. Down here. Serial print. Every time we write serial, we're going to work with the USB connection in our case. And print is just like when you're printing to, let's see, I'm sure if I connect to the serial monitor, we should get some input. See, it's right here. There you can see, that's my input. And I'm constantly sending this input to the PC. And as you can see, it's comma separated, but it's also only in one line. So serial print, byte 1, 0, 1, temperature and light. Well, what's this? What's this byte? Well, we're going to see that in a minute. But what we want to know is these values are separated by comma, not a punctuation. That means the first two numbers, 0, 0, is these two values, input byte 0 and input byte 1. Then we have a comma, that's this one. Then we're going to read temperature and send that to the PC. The temperature is this one. You can see the last one is 20.31. And the last one is the light value. You can see we got 106, so that's a bit strange, 106%. So let's just see if I'm going to hold my finger above it now, so you can see, yeah, that's 10. It works. That signal is continually being sent to the PC every 5 seconds. And that's because we have this 5-second delay. So that kind of covers sending the signal to the PC. And the way we're going to uncode the signal on the PC is something we're going to look at in the C# section of the video. Right now we're just in the Arduino. And if you want to call this language anything, it's more like a C++. This part right here, that's the reading part. So when the PC or whatever you're going to connect is sending the signal to the Arduino, that's this one. So first of all, it's just going to check, is there a signal? This just means, is there a signal? Because the signal is going to be stored on bytes on the chip itself. And it's just going to stay there until you clear it away. So if there's any data available there, it's going to check, is there data? Yeah, there is. Okay. Then we're going to turn on the light, the yellow one, which indicates we're now reading data or receiving, if you want. And we're going to peak. Yeah, and it does mean peak. We're just going to look what it's actually doing. It's going to look at the values, and it's going to look for an E, a capital letter E. So it's just skipping through all the data and finding E. There we go. This thing just reads the E and does nothing with it, so we're going to skip the E. In fact, we're going to take the E out and throw it away. Then we're going to read the first value after the letter E. And the first value is we're going to call incoming byte 0, and we're going to read it as a number. That is what this means. We're going to read it as a number because when I want to turn things on and off, I just send it as a value 0 or 1, and I even use 2. Value 2 just means no change to the current state. So if I'm sending a lot of signals and I only want to control a single part, but because of this code, I have to send the entire string each time, a lot of 2s will be in there, and the 2s just mean ignore this and move on. But right now we're just getting the numbers. And the same again, it's going to, after reading the number, it's going to take the next letter, because I know how the string is built. I'm sending a letter, a number, a letter, a number, a letter, a number, just for me to be able to read it myself. Take the next letter and throw it away and read the next number. And that's actually what we get here. Right now it's reading 0 for this one and 0 for that one. Off and off. That about covers the entire Arduino code. That's it. These down here is this entire part right here. Sorry. It's just to clear the rest of the memory on the Arduino if it's receiving, I don't know, mail functions or whatever. And there might be extra bytes in the data. It's just going to read it out and throw it away. So as long as there's data available, just remove it after reading, of course. Then I'm going to react to what actually happens. So K-switch incoming byte 0, that's actually the only one I'm working with. So if I wanted to work with multiple, I would have to do multiple of these. But for 0, that's this one, I just turn the light on or off. And when done, or if there's no data available, turn the yellow light off. That's why the yellow light is on for 5 seconds minimum, because it's actually going through the entire program and checking, okay, there's no data now, and then we can turn the light off. That's the Arduino code. I'll put a link in the description. Now let's cover the most interesting part. Well, this is a Visual C, so when you're going to create a new project, I did this, and you can see it says Visual C#, Windows Form Application. This is the one I used. And I just design my functions as usual. And if you don't know how usual is, well, you basically take a text box and you just click it in, and there you go, you got a text box. That's it. But the next thing you need to do is these text boxes. Let's see, this is the temperature text box. Click that once, scroll down over here, you can see there's one called, let's just make sure you can actually see it for my webcam. There you go. This one. It's called text box 1. That's a that's a bad practice to just leave it at the default name. You should name it something it's representing, just like this. You can see there's a checkbox. And this one is actually called LED box because I'm turning a LED on and off. This one up here is called a light box because I'm getting the value from the light on the Arduino. Over here I got the COM board, and I'm actually calling it a COM box, board box, and so on. Test box. This is just for me to send test values to the Arduino, and the debug thing here is just to read the byte 0 and byte 1 from the Arduino back to me, so I can see what am I sending and what is the Arduino actually receiving. Is it receiving 1 or a letter or whatever? And I get the data back here. This is not something I would have in a finished program, but as long as I'm developing on it, that's it. Now for the code. All the code is only on this single button. That's why I have the button, because otherwise you could write a loop that it would just go through the loop all the time. I like to do it this way. So let's double click the button and you get all these things. But if you notice, Visual Studio automatically set the cursor right here. That's because this is the part we're working with. This one right here. That's all. And all the code is right here. This is it. Yeah, I can hear that. That's the dog. Excuse. Mia. Yes, he's sad because we're home alone. Kom så. Kom så. Yeah. So, well, anyway, back to work. Let's go through the code. There's one thing I forgot to mention. It's very important to add this thing in the Visual C#. You can see it's called My Serial, and it comes from the toolbox right here. Let's see. There we go. Serial connection. That actually tells the Visual Studio that we're going to work with the serial connection. Just put it in there, and the only thing I really changed is this one over here. You can see it says My Serial. So whenever I type this in the code, it represents this component. Back to the code. Because then you can see the first thing I do is type my serial dot port name. And I said the port name is the one I have defined up here. You can see it's COM4 by default, but if I were to connect another Arduino or change it in some way, it's nice to just be able to edit it on the go without having to change the code. And that's what I'm doing here. The baud rate, I'm going to change that from a text into a integer, because this is actually a text box. It's not a number box. So I have to convert it into numbers before sending it or making it into a value. And then I'm going to open the connection to the Arduino. My serial string, well, it's nothing yet. As you can see, I'm just defining an empty string called my serial string, or in short, my serial string. And serialization, as I've called, it's basically taking the data I want and compact it into a single line and send that line instead of sending multiple lines, because sending multiple lines is going to be a problem with the Arduino, because it's actually only able to read 1 byte at a time. I know there's a new function called read byte, but it's working like shit, or I don't understand how it works. Either way, this works, so I'm going to work with that. And the first thing I'm going to do is check the let box. If it's checked, if it's true, then set the string to E1. If you remember the Arduino code, I actually closed that for some reason. Let's open that again. I think it's on the sketchbook, and it's temp read, I think. There we go. You can see peek at E. Look for the letter E, it actually says in English. And the first thing I enter is the letter E, and then the number 1. If the box is unchecked, then I'm going to write E0, and it's just going to read the 0 and ignore the E. Then I'm going to add some context, because I have this test box right here. You can see it says T6 right now. Let's actually start it again, the program, and update. You can see I get 6. So if I write 8 here, I should receive 8 back. 8. And if I turn this one, it should say 18. There we go. Turn it off, and this one 0. It should say 0, 0, because the first number indicates this part, the second number indicates this part, ignoring the letters again. So, by doing it this way, I could actually also just replace this with a T, and it would skip everything before the T and read from the T and forward. I could also just build up multiple peaks and check in different connections before clearing the memory. So I can read several bytes at the same time. Or not really at the same time, but it's close to instantaneous. Then this string is actually, now it looks like this, something like this. I'm just going to type it right here. You can say it's going to say E0T1. This string is the one I'm going to send to Arduino, and I could build it up in infinity. It doesn't really matter. The point is, I'm already doing an error because, as I explained before, I'm only sending 0, 1, or 2, where 0 is off, 1 is on, and 2 is ignore, meaning if there's no change, ignore the current state, but I haven't written that into the code yet. That's a thing to do for a more advanced system. Serial write line, it's just like on the Arduino, and write this string, you can see it right there, to the Arduino. Then that's actually done. We're done sending the data. This is receiving the data, string, my serial read line split. Well, yeah. This is going to take all the data from the Arduino into this array. These two are defined, meaning it's an array called myString. And it's going to read the line from the Arduino, remembering the Arduino is sending out a line every 5 seconds right now. And it's something like 0, 0, a temperature, and a light. So it's actually going to put the 0, 0 into string 0, temp into myString 1, and light into myString 2. Then I'm simply going to update all the values into the text boxes, meaning the temperature gets in there, the light gets in there, and the test value gets put into this one. And then I'm going to close the connection. And there we go. Done. Let's hit play. Let's watch it again. Update. There we go. Connection T6. That means I'm receiving a 6 there. Turn this on. It should say 16. Yep. And if you want to make sure this program reacts faster, it's really simple. You just need to make sure the delay is a lot slower. So instead of 5 seconds, maybe make it a half a second or something like that. And that should really improve or speed up the process of the communication between the units. But I'm doing the 5 seconds to reduce the power usage of my Arduino because this function is going to be run on a solar battery. And I want to keep the power usage very low. And before we finish, I just want to show you a project I'm working on using the same thing. This is this one. This is a greenhouse controlled with my own SCADA system. In the same way, I'm reading water gauges at the greenhouse in the dirt to measure how much moisture is in the water. If the moisture gets below a certain value, the pump is going to start, and we're going to pump water into the greenhouse using something like this. Let's see. There we go. And for that, I'm going to use some pumps that's just going to be put into the rainwater tank. That's this one. And you can get small 12 volts, or I think it's 12 or 9 volts pumps. That's fine, but they're going to be started and stopped by the Arduino. Also got the temperature gauge inside and outside, and that's actually for... My intention is to add a controlled airflow, meaning I'm going to add I don't even think I have one right here, a computer fan in a pipe that's going to air out the greenhouse if it's going to get too hot in there. It gets very hot in the greenhouse at sometimes. And the point of the long delay is this part over here. Need to add a few gauges to actually control, so I can see remotely, even though my greenhouse is maybe 50 meters away from here, that I can see the battery is actually charging and voltage down here. So this is work in progress, and I also want to, you can see I got manual and automatic. That's just pump control. I want to be able to force water if needed. So if I need to add extra water, I can do that. And I'm going to add a second silo where we're going to be able to insert fertilizer into the water system, or maybe add a separate system. The point is, the power and the water is going to be free or natural. I'm not going to add anything from the house. So that's why the solar panel and rainwater. And rainwater is actually from the roof of the greenhouse. So it's just standing there collecting plenty of water. I hope you enjoyed my project and my little walkthrough, if you want, of how I'm actually able to control my Arduino using C#. Thanks for watching. Comment, rate, and subscribe. And I think I'm going to add more Arduino control videos because it reminds me very much about Minecraft, actually. It's just like Red Power in Minecraft, except this is real life. And it's a lot of fun. Thanks for watching. I'll see you next time.